Hi class, we're going to take a look at the comparable interface and how that allows us to sort objects of different types than what Java might be used to. So I think I'm going to use NetBeans here to create this, and I'm going to start with a new project. I'm going to call it comparable objects. That's what I would like to call this. And I do want to create a main class, but I would like to call it main, so that if my instructor were to make me copy it to REPL, it would copy, right, without any sort of problem. So let me finish. And now that I have my project here, let me close some of my others so that we're focused on this one. And looking at our main here, we've got not much going on. So what I would like this object to be like is I'm going to create an array of circles. And if you remember in our chapter before we had our unit exam, we were looking at inheritance and how we could start out with an object like a comparable, like just a geometric object. And from that, we could inherit a circle. So you had an assignment that involved taking some existing code and changing it and adding a rectangle to that code. And I hope you found the exercise at the end of that chapter in your textbook that showed you pretty much exactly how to create that rectangle. So given those resources, let me know if you had issues in putting those things together. We're going to take some of those resources here to create this new project. So I want to use my geometric object class. So I'm going to find that assignment in REPL. It was the Week09, the rectangle class assignment in REPL. And I'm going to copy all of the code for my geometric object class. And then in NetBeans, on my default package, I'm going to create a new Java class called geometric object. And then I'm going to paste that code that I copied from REPL. So if we look, we should see we have our abstract class, geometric object, and remember an abstract class is one that does not have enough details to instantiate an instance, but it can serve as a base, a superclass, a template, so be it, for another class. So this abstract geometric object, we can't create an object because it's just too abstract. But we know that if we do create a geometric object, we want to have the ability to get the color and set the color for that object, determine if it's filled, and we are going to enforce that the object must implement a method called getArea and must implement a method called getPerimeter. We made both of those abstract in our abstract class, which means that any derived classes must implement those methods. Okay, the next thing we want to create then is another new class, and this will be our circle. I'll go back to REPL and copy that code for our circle. And paste it in NetBeans. And now we've got our circle object here ready to go. So all of that looks great. Now for as far as our main goes, I'll go ahead and copy that example main that was supplied as the startup code. Make sure I didn't make any errors. Everything looks good. I'm not getting any errors. I'm going to execute this. And sure enough, for the test that's being run, it says that we have a circle with a radius of 5 and a circle with a radius of 1. Now if I look at our circle class, I want to check out Where is that coming from? Oh yeah, it's coming from our toString method. Remember, our toString method overrides the system object toString method, and we will return some string value that equates to information about our object. So for our circle, we're returning information about the radius of our circle. So in our main, when we create an instance of a circle, and then we use that instance name in our print line statement, the system runs the toString method. So we could actually say .toString, and that would give us the same results, because the toString method is the default method that's run when we name the instance of an object. So here we've created some circles. Well, I'd like to create an array of circles instead. So I'm going to get rid of this and create an array of circles, and call my circles, and we'll call it, we'll say that we're going to maybe have 5 circles in our array. Now, as I create instances of circles, I can say, oh, you are a new circle and you are 10 is a radius. And so, and then when we come back from creating that circle, we could print out information about it. My circle, index location 0. And we should be able to run that. So we created an array of circle objects, and we added an actual circle object to that array, and then we printed out the information about that circle object. So that's awesome. Let's go ahead and fill up our array. I'm going to use a for loop. I'm going to create an integer named ix with an initial value of 0. I want to run this loop while ix is less than my circles array length, and I want to increase ix every time my loop is run. Now what I can do is inside my loop say in my array at position ix, whatever the value of ix is right now will be my index value. I would like to instantiate a new circle, and I want my circle size to be, what do we want? The value of ix? Does that sound okay? So my circles equals a new circle. Then when we get back from that loop, let's use another loop, and this time we'll use a for each syntax, and we'll say for each circle called circ in my circles, I would like to print out the information for that circle called circ. So that for loop will execute and we'll run our print statement for each, once for each occurrence in our array. So let's run it. Okay, there we go. So we created an array with 5 entries based on the length of our array. And for each of those entries then we added a value. So that's great. I'd like them to be kind of in a different order though, because they're already sorted, and I want to show you how we can implement a comparable to sort things correctly. So let's do something a little different. whenever we create a new circle, instead of using the value of ix, which is starting out at 0, etc., I think that I want to use the value of my circles dot length, so the size of our array minus the value of ix. Now, let's see if we get something a little bit more in descending order. Sure enough, that's what I wanted. So looks good. I've got these circles now, an array full of circles, and I'm just only printing out information about their radius. I could print out some additional information if I wanted to about the circles. We could say circ.getArea. Let's see, I better put something before that. The area equals circ.getArea. Let's run that. And now we see the return value from our getArea method for each of our circle objects. So this array contains a lot more than just one piece of data, right? It contains circle objects, and each circle object has many different properties. Those properties and methods that are part of that circle object are available to each instance of the circle object that we created in our array. So there they are. There are our circles. We could output more information about our circles if we wanted to, like if they were filled and what color they are and things like that. But we would get a lot of default information when at Weeks we haven't done a lot with our circles to customize them. But we have that capability because our circle objects can be customizable. Now, looking good here. We've got everything ready. I'd like to sort now these circles back into their original order. And we know that we can say arrays.sort, and then I want to sort my circles, because we saw that sort was a method that was available to the arrays class. Now I do need to add the import. Excuse me. For our arrays library. So that looks good. I've got my sort, and then I think I'm just going to copy this for loop again. Getting some good data there. Let's run it, and we see that we crash like a big dog, right? We did not get past our sort. So we get started printing out some information. So NetBeans sort of mangles up our exception reporting with our output, but we actually got to this line of code where we were printing out the radius of our first circle, our last execution of the loop, and then we crashed because it says, look, we're trying to sort, and I do not know how to sort circles. It says here, circle cannot be cast to java.lang.comparable. And comparable means I need to know how to compare these objects one to another so that I would know how to sort them in order. So we need to implement the comparable interface for our circle objects so we can identify how to sort them. So let's do that. In our circle class, we're going to find our class statement. On our class statement right now, we are extending the geometric object. That means that circle, right, is a child of our geometric object parent or superclass. So we've got an extension here going on already, but we can still go ahead and say that we implement the comparable. In the comparable interface is an interface that says we are going to create a method called compare_to, and in our class you'll be able to find that compare_to method. You'll be in the Java runtime system. We'll be able to find our compare_to method. So in our compare_to method, we'll implement code that allows the Java runtime system to sort our circle objects. So as soon as I put in this code to implement this comparable, and we'll talk a lot more about interfaces in semester 2 of Java. For now, you could just know that this is how we implement the comparable interface because it's quite handy, and it comes in really handy for arrays. As soon as I put the implements keyword, I get an error because the circle is missing a method. And what method is it missing? That compare to method that I mentioned. So I'm going to code that method right here after our constructors. So I will make this method a public method, and it's going to be static. It's going to be static because I only want to be comparing one circle object to one other circle object at any given instance so that I can allow the system to sort those objects in the correct order. So static implies that I would only have this method in memory once, so it would only be executed one at a time. Now, our method is going to return an integer value that indicates which circle object was bigger or larger. Okay, back up. I do need the outside override again, and I don't need the static keyword, but I think we might try implementing that at some point and see if we get errors, because we'll just go on without it. But for now, we're going to say that we are returning an integer that indicates which object was larger. Our method is got to be named compare to. That's the requirement of our interface. So we have to name it compare to. It has to return an integer, and it has to accept as an input parameter an object. And we're going to name that object O. Now for us, since we're working with our circle class, we're going to know that that object is a circle object. So we're going to create a variable here called the_circ, and we're going to set it equal to the object that was sent to us, but we want to cast that as a circle. So now we know for sure that we're working with our circle object, right? And it is named the_circ. Now, to continue on, we just need to decide if this object that we're working with using its getArea method is less than the area of the circle that was passed to us, the_circ. We're going to return a value that is less than 0. This object is less than. Now, if this object's area is greater than the circle that was passed to us's area, we're going to return a positive value. Otherwise, the objects must be equal in size, so we'll return 0. So this instance is greater than the other. Past instance is greater. So we're just deciding which is greater. So because we've implemented this compare to method, and we said that we implement the comparable interface in our circle object, we should be able to sort now. Let's see. So we've got everything we need. Let's try it. That seems awfully easy. Sure enough, there it is. Now, here was our first information where we went from largest to smallest in our output. And then after we sorted, we're going from smallest to largest because we sorted those circles based on their area. So that's how easy it is to implement the comparable interface. It sounds really complicated, but it's actually just a really easy to use thing. It's just a way for us to say, based on my type of object, which field is the most important, and that's what I'll put in my compare to method. So if I were working with students and I wanted, to sort them by GPA, then my compare to method would compare GPAs, and that would be enough for me to sort that way. So really handy, really useful. I hope you are able to get a lot of benefit from it as you go through your Java career, and I think you will. Thank you.